This is part 2 of the predictive move system, so make sure to watch the previous one first if you haven't. Now we will start with the character blueprint. Open yours. If you haven't followed along the previous episodes in the Parkour series, your blueprint won't look like mine, but I will try my best to explain how to code it for any project. First, go to your enhanced movement input and promote the action value X and Y to variables called move X and move Y. This was added in the wall climbing part 1 video. Then replace both respective scale values to use the move X add move Y variables in the add movement input nodes. Now make a Boolean variable called onPredictivePoint. Multiply move X and Y by not of onPredictivePoint before plugging it in. It will automatically convert the Boolean to a float, where false gives 0 and true gives 1. This makes it so the player can't regularly move with movement input while on a predictive point. Next, open the getInputDirection function. This is a function I made in the beam walking video, which I will link in the description if you want to make just this function. You can also pause and copy it. Replace the getIA_move with the move X and move Y variables. Now go back to the event graph and make a custom event called cancellation. Get the character movement and set the velocity. Split the struct pin. Get the current velocity and connect only Z. This event will cancel out any planar velocity, so only the root motion drives the movement during it. Make another custom event called Predictive Rotate. Add a timeline called Predictive Rotation. Set the length to 0.2. Add a float track and add 2 points going from 0, 0 to 0.2, 1. On update, set the actor rotation to alert rotator node. A will be the actor rotation and drag B into the event node to make it an input. Rename it to target rotation. The alpha is the timeline's value. Finally, enable shortest path. This event will quickly and smoothly rotate the player to a target rotation. Make another custom event called reset predictive move. Make 3 vector variables called predictive start location, end location, and land location. Set all to 0 in the event. Since a lot of variables will be made, I will categorize them so it is easier to read and access. Now make a rotator variable called Predictive Rotator and set it to 0, 0, 0. Make a Boolean called wasNewTypeDetected, setting it to false. Then make a Montage variable called randomMontage and set it to empty. Then make a variable with the type being the random animation struct we made. Set it and make a struct for the value with both values at default. Make a new Boolean variable called forceFalling and set it to false. Then clear timer by function name with the name being cancel velocity. Make sure it is named exactly as the custom event you made for it. This event resets variables used once predictive move ends. The variables here will be explained when used later. The next custom event will be called current point trace. Add a sphere trace by channel. For the start, get the mesh's world location. For the end, subtract 100 from Z and set it. The radius will be 20. Change the trace channel to move point so it only detects for movable objects. I will promote the draw debug type to a variable so I can test it easier later. Add a branch using the trace's return value. Then break the hit result and promote the hit actor to a variable called current closest actor. Set this if true and get is valid of it. Set this as unpredictive point. If false, set both to their default values. This event will detect which predictive move object we currently are on by tracing down for 1. We will make 2 more custom events with the first one being called start current point timer. Set timer by function name with the function name being current point timer. Set the time to 0.01 and looping to true. The second event will be called clear current point timer and it simply clears the timer. Now make a function called get closest actor to camera. Make it a pure function. It will have an array actor input called actor array and a vector input called target direction. Add a for each loop using actor array. Get land position of the array element in loop body. Then get the actor location and find look at rotation between it and the land position. Quickly make a new function called get your rotator. It will have a rotator input and output. Break the input and make a rotator with only Z for the output. This returns just the yaw component of a given rotator and is made into a function since it is repeated many times throughout the video. Get the rotator of the find look at rotation and make sure to set it to pure. Then get the forward vector. Get the target direction input and get the dot product of this and the forward vector. Then make a local variable of type float array called compare dots. Now we will do the main predictive move trace function. It will have one float input called trace radius of default value 250. Add another float input called trace forward amount of default value 275. The last float input will be called predictive movement max angle with a default value of 180. Next, make an actor array local variable called found objects. Clear it. Add a multi-sphere trace by channel. Copy the shown nodes for the start and end. This makes the trace be in the input direction with the camera rotation being taken into account and then offsets it by the forward amount input. The radius will be the trace radius input. For the actors to ignore, add a select node. For the index, check if current closest actor is valid. If false, leave as empty. If true, make an array with current closest actor being the only element. This makes it so that you can't predictive move onto the current same object you are on as it is ignored by the trace. Add a for each loop using the outhit array. Add a branch in loop body and break the array element. Add a does implement interface for the hit actor with the interface being the movable object one we made. This is the condition. If true, get the land position of the hit actor. Then add another branch. Get the distance between the land position and the actor location. Check if it is in range of the predictive move min and max distance for the branch condition. If true, add the hit actor to the found objects array. This code filters out actors that are movable objects and are within range of the given distance values. On completed, add a branch that checks if found objects is empty. If true, add a return node. Add a boolean output called canMove and an actor output called closest actor, leaving both at their default values for this. If false, add another branch. Get the found objects array and get closest actor to camera with it. For the target direction, it will be the fixed input directions forward vector. Check if the closest dot product is greater than 0.75, which is the minimum closeness factor to detect a movable object. You can change this value if you need. I will promote it to a variable as well. Set this as the branch condition and promote closest actor to a local variable called closest if true. If false, add a default return node. After setting closest, add another branch. Find the look at rotation between the closest actor location and camera's world location. Split the pin and get the absolute value of yaw, which returns the magnitude ignoring the sign. Check if it is less than the max angle input. This ensures that the predictive move object is within camera view based on the given input. If false, add a return node. If true, copy the shown nodes. If true, add a return node with canMove set to true and closest actor being the closest local variable. If false, add a default return node. I will now comment the function. I will also categorize the functions. Next, make a function called Predictive Move Has Gap. Set it to pure. It will have a float input called trace down amount of default value 100. Get actor array average location with the actors being a make array with self being element 0 and promote element 1 to a variable called closest predictive actor. Then add a sphere trace by channel. Copy the nodes shown for the start and end. This traces downwards to check if there is a floor between the player and the target predictive move object. The radius will be the capsule component's radius. Add a return node after the trace. Drag out of the return value and add in an operator. The second condition is if the distance between the closest predictive actor and self is greater than 300. You can adjust the value here if needed. Set this as an output. This function makes it so that if the player detects a predictive move object, but there is a floor between them, it will not move to it until they are closer to the move object. This is required more for when the player goes to the first predictive move object while on a regular floor. The next function will be a quick one called random animation selector. Give it an input called animation array with the type being an array of the random animation struct. Give it an output called animation of type random animation struct single. Get a value from the input with the index being a random integer in range between 0 and the length of the array -1. We need to subtract 1 here since arrays start from 0 and not 1. Set this as the output and make the function a pure one. Now make a function called predictive move land trace. It will have a rotator input called forward direction. Add a multi-sphere trace by channel and copy the nodes shown for the start and end. Set the trace channel to move point. Make an array for actors to ignore with closest predictive actor. This traces ahead of the player and below in the direction they will move to trace for potential landable objects. Add a for each loop using the out hits and break the array element. Add the hit actor to a local actor array variable called found actors. On completed, add a branch that checks if found actors is not empty. If true, it means a movable object was found. Get closest actor to camera using the found actors variable. For the direction, get forward direction and get the forward vector. This finds the closest actor to the player's forward direction rather than the camera. Set the closest actor output to the closest predictive actor variable. Then get land position and set it to predictive land location. Now get the motion warping component. You can add this if you don't have it. Add or update warp target for this and split the pin. The location is the predictive land location and change the name to land, making sure it is case sensitive to how you named them in the montages. For the rotation, find the look at rotation from the actor to the land position and get the rotator. Then add a return node. Add a Boolean output called continue land. Add an actor output called hit actor. Add a rotator output called rotator and set it to the same rotation. The montage should be the falling exit one. Add a return node with found set to true. The location will be the initial hit results location. I will now comment the function. Now go back to the predictive move land trace function. If this branch is false, call the exit predictive move trace function. The start and end should be the locations of the first trace. Add a branch using the found output and set predictive land location. Subtract the default capsule height divided by 2 from Z from the location for the land location. Duplicate the motion warping nodes and adjust the nodes as shown. Aim, check next, jump end, reset collision and set falling. These are the montage notifies we added in the montages, so make sure they are case sensitive to be exactly like those. Check next is a notify that checks if the player should check for a new predictive move object mid-animation. Get the closest predictive actor and get type. Switch on the type and add a branch if swingable. This means a move can only be interrupted to switch if it is a swingable one when the notify is called, which we only added in the vaulting animations. Check if was new type detected, and if false, add a montage stop with a blend out time of 0.25. Leaving the montage empty will blend out the current montage. Then set the movement mode to flying. Next will be jump end. Set the movement mode to flying here as well. Then make it an output called on jump end notify. We will come back to this part later once we do the movement input. Next will be reset collision. For this, simply set actor enable collision to true. This is called in vaulting, as collision will be disabled during it and this resets it once completed. Finally, for set falling, add a branch that checks force falling. If true, set the movement mode to flying. Stop the montage and add a retriggerable delay with a duration of 0.25. Then set the collision to true as well. I will now comment the macro. Next, make a macro called exit predictive move. Add a branch and make the exec pin and condition an input called can exit. Then add a vector input called exit location. Add a float input called exit z offset with a default value of 120. If true, stop movement immediately, set the velocity to 0 and set the movement mode to flying. Add or update warp target for motion warping and split the pin. Set the warp target name to peak pause and for the location get vector array average. Make an array and set the first element to the exit location input. The second element is the actor location. Then find the look at rotation between the actor location and the exit location. Get the rotator and set it as the warp target rotation. Then set predictive land location to the exit location with the exit Z offset subtracted in the Z axis. Duplicate the warp target and change the name to land pause, setting the location to the land location. The rotation is the same as the previous one. Then call the predictive move macro, and for the montage, get selected montage and split the pin. On blend out, call reset predictive move. Now we will finally add the movement input code, which will incorporate the functions and macros we have made so far. Again, my code is different due to the previous videos in the Parkour series, but if you haven't followed along, just add this code right at the very end of the move input. First, add a branch that checks has predictive jumped. Make a custom event called predictive move event and connect it to the branch as well. This enables the predictive move code to be called externally if needed. If false, add another branch that checks if falling. If false, add the predictive move trace function. Add a branch using the can move output. If true, add another branch. This is since the target object's different in Z is negative to the player, meaning it is below them. If false, add a branch that checks the greater than 50. If true, add a branch and copy the following nodes for the condition. This condition is simply checking if the object is close and not too high above the player, meaning it should be mantle, otherwise a step up. Set the animations accordingly in true and false, with mantle jump having an offset of 150 and step up having an offset of 50. These offset values are ones that were tested to ensure they work, but you can modify them as you need. If the previous branch was false, set the montage again. Copy the nodes shown. Add a select node for the montage and add the shown nodes. Choose the animations shown. This code picks the small jump if the distance to the object is shorter than 250, and if not, then either a big jump or running flip based on a threshold value of 400. In the sequences, then 1, add a reroute node. Get the peak position of the closest predictive actor and add the following nodes for motion warp settings. Finally, call the predictive move macro and set the montage to the selected montage. I will now comment the code up to now. Now we will do the vaultable path. Set the selected montage to a random animation selector and promote the animation array to a variable called vaultable animations. For the default value, add 3 elements. Copy the same offset values for each animation. Get the closest predictive actor and cast to vaultable object. Do the same for the right hand one. If false, call reset predictive do once. Next get closest predictive actor and get land position. Copy the nodes shown for the motion warp settings. Then call predictive move land trace and set the forward direction to the same rotation. Call predictive rotate using the rotator output. Then call the predictive move macro and set the montage to run and swing. Integrated with the Parkour series. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.